Hello everyone. So in this particular video, we are going to learn SQL. And in this video series, I'll be covering up everything from very basic to very advanced. We'll be talking about what is RDBMS. We'll be talking about how you can write a SQL query and how you can use advanced SQL. So in this particular video series, we'll be covering everything. If I talk specifically about this particular video, we'll be starting with the discussion on what is RDBMS and how you can basically understand the concept of database and table. Then we'll be also talking about the various vendors which is available in the market, for example MySQL, MySQL, PostgreSQL, and then we will be understanding how to write a basic SQL query. So this is what all we are going to do in this particular video. But before we start this video, don't forget to give this video a big thumbs up, share this video with your friends who is looking to learn SQL, and don't forget to subscribe to our channel, which is Session with Sumit. So let's get started.
Before we talk about what exactly is SQL, let's try to understand the problem behind it. Why the technology, something known as SQL, was discovered or maybe invented or came into existence. Why we need SQL? So let's understand the problem first of all. Now, let's assume that there is a multinational company, and here we are taking the example of the company Amazon. So there is a company Amazon. Now this company, so all of you right now already know that Amazon is a multinational company, and they have a lot of data, and their data generation speed is exponential. So every day they are generating high amount of data, right? Now assume that if they prefer to store their data or manage their data in the form of Excel files or maybe PDF files or maybe pen drives or maybe hard paper documents. Now, if they prefer to preserve their data in any of these storage system, which we call as the traditional storage system, or maybe these are known as traditional storage system. So if they prefer to store their data, manage their data in any of these traditional storage system, what do you think will happen? Is it going to be good for them, or is it going to be bad for them? And if it is bad for them, then how it is bad for them? So can you guys quickly come up with some reason or maybe some problems that the company would face if they prefer to use any of these traditional storage system? You may put your answers on the chat section. Number one is, the data is huge and it is getting regularly increased. The growth is regular. And to manage that much amount of data with these traditional storage system is difficult. So the very first problem is data is huge with regular growth. The second problem is with the management, because when you have a lot of data, you will be generating a lot of Excel files, a lot of PDF files, and it will be impossible for you to manage everything, right? So next problem is with management. The third problem is it will be difficult for you to input the data, to preserve the data, and get your data retrieve, to get out of the data when you have to search a specific information, right? So difficult to input and fetch the data. The next problem is with the security, because if the company wants their data to be secure, these traditional storage system, I don't think they provide a very good level of security, right? Because everyone can easily access Excel file. The only security that you can add in Excel file is a password, and which is something which is easy to crack if you know C language. So security is another problem. These are the major problems that the company would face, right? But now let's try to understand each of the problem in much detail, because the reason we are putting so much time and effort in understanding the problem is because once you are clear with the problem, you will understand why some technology was invented or came into existence. So let's understand each of these written problems, which I have written over here, in more detailed way. The very first problem that we have discussed is data is huge. So data size generated by Amazon is huge, and these traditional storage systems have their own limitations. So this is my problem number one. All these traditional storage system which we have over here, they come there with their own limitations, right? The second problem is, and this is the most important problem, logical collection and arrangement of the data. Logical collection and arrangement of the data is not possible, and hence Amazon would face issues with data ingestion and retrieval. Now, what is the meaning of this? Let's understand this problem. So, we already know that Amazon is a multinational company, right? And it deals with a variety of business. So, Amazon is having e-commerce business. So, let's write it down. Amazon is having one of their businesses, e-commerce, e-com. Then they also have their business regarding Amazon AWS, which is Amazon Web Services. They also have Amazon Entertainment and so on. So variety of business they are running right now. But if I only focus in one of their business, let's say Amazon e-commerce, then they will have a variety of data, right? They will have the data of various orders. Now each order will be associated with a customer. So there is a customer involved with each order. And then each customer will have their customer-centric details like email, password, gender, payment method, and maybe the last order. So a customer will have a variety of details. I have just written few of them. Then each order will be associated with a product. So which product has been ordered and what are the details of those product. Each product will be associated with a vendor, because I hope everyone already know that Amazon is a marketplace which connects various vendors with the customers. So here we have vendor specific information, and then each vendor will have their own details. So vendor specific information. Similarly, each order will be associated with a delivery partner who is going to deliver this product. So delivery partner, and then it will have the delivery details, delivery details. Then there will be some financial details also, like what is the order value, what is the GST amount, what is the discount offered, what is the final amount. So financial information. Now you can see that one particular order which a person places in Amazon is having a lot of associated details. A order will have a detail of a customer. A order will have a detail of various financial information. A order will have a detail of product. Product will be associated with vendor. Then order will have a detail of delivery partner. Delivery partner will have a detail regarding delivery. You can see that how the data has been linked to one to another, right? Now this is the problem that Amazon would face if they want to use any of these traditional storage system, because you cannot preserve your data in this kind of mesh format or the network format where each node is connected to a particular branch. So you can see a branch like a structure happening over here, and using Excel, PDF, pen drive, you cannot preserve your data in such a way, right? So this is the second problem. The third problem is more sophisticated and one of the major problem due to which these kind of technology was discovered. Same view of the data is not available. Same view of the data is not available. So what is the meaning of same view of the data is not available? Let's try to understand it. Let's say there are two employees. There is one person whose name is Sumit, another person whose name is Shreya. They both are working on a particular project, and let's name the project as P. Now, since assume that right now we are managing all the information in Excel files. So Sumit is having one Excel file, I'll call this as E1. Shreya is having another Excel file E2, but these two Excel file belongs to the same version, or maybe they belongs to the same master file. This is the master file E. So Sumit is using one copy of E, Shreya is using another copy of E. Now if Shreya is going to do any kind of change in her file, it will not be replicated to the file owned by Sumit. And if Sumit is making any change to his file, it will not be replicated to the file owned by Shreya. So there will be a synchronization problem. If Sumit is doing some kind of analysis on his piece of data, which he has manipulated according to his logical thinking, it will not be replicated to Shreya. They always have to connect, they always have to share the details, they always have to perform what is known as the knowledge transfer. And it will take a lot of time, right? Now, the other problems which are very simple to understand and are general is the time loss. Time loss because it will take time to input the data, to retrieve the data, and to search the data. And another is data security. That is something which is everyone can understand. So here you can understand that these are the kind of problems that the company would face, or any company would face, if they prefer to use these traditional storage system. Now let's understand how we can solve this problem. So in order to solve this problem, a technology was discovered in the market, and technology was introduced in the market, which was known as RDBMS. RDBMS stands for Relational Database Management System. This is the technology that was introduced in the market. Now, what is RDBMS? RDBMS is basically a particular technology tool which comes with two components. The first component is known as the server. The second one is known as the client. Now, what is server? What is client? Let's try to understand it. First of all, let's understand server. Now, server is basically the central data storage. This is my server, and this is the data storage. Now, those of you who do not know what is a server, let me just quickly help you with one short video. So here what you are looking into the screen is what a data center looks like. You can see there are variety of racks which are kept together. They are all connected in a network to create a huge storage space. So here these are known as the rack, and each rack comes with a storage device, or maybe a complete computer, which comes with a processing power, that is CPU, and your storage device, which is your disk space. So here, this is the smallest unit of a server. It is basically a particular computer which is having the processing power and having the disk space. Now this is a disk space, or maybe a hard drive, which is the smallest unit of a data center. The server is basically the central data storage, and then we have what is known as client. Now client is nothing but a software which is running on a user's laptop or desktop. So let's say this is the laptop of the user, and we have a software which is running on top of this laptop, and this is the user. This is the user, let's say Sumit. This is the laptop that Sumit owns, and this particular screen which you are looking right now is basically the software which is known as the client. So client is nothing but it is a graphical user interface, also known as GUI, which can let the user interact with the server. So if I have to interact with the server, if I have to write down any requirement, if I have to perform connection, if I have to connect with the server, I have to use client, which is the GUI, to perform all kind of interaction. So that is what client is. Now you have a security layer between these two components, which we call as a firewall. So this is my security layer. firewall security. Now, if I have to connect, or if a user has to connect to the server, they will use the client interface to perform the connection. So Sumit will use his or his credentials, which is user ID and password, which the user, which is Sumit, has to input in this client software. Client will transfer or send this request to the server. The firewall will verify whether this credentials are valid or not. And once it is valid, the connection will establish. So you will be able to connect to the server. Now, if Sumit has to get any kind of information from the server, then Sumit will be using a particular kind of language. So if Sumit has to get the data of top 10 customers, now Sumit will be required to write down this requirement in a form of a language which we call as SQL. So Sumit will write down his requirement in a form of a SQL query, which is transferred to the server. The server will process it and will return the output back to the client, which Sumit can view and can analyze, or maybe can do anything. But that is what SQL is. SQL is basically a communication language. Please remember one thing: SQL is not a programming language. SQL is a communication language. And using SQL, a particular user can communicate his or her requirement to the server, and the server can understand that requirement. Now, SQL is very simple. It is simple. It is case insensitive. And it is like simple plain English. So the way you talk, the way you write a SQL query, and we will talk about that, how a SQL query is written. But this is what a SQL is. This is what SQL exactly mean. It is a communication language that help the client or the user to write down his or her requirement in a form of a SQL query, which get resolved by the server. So now we are clear with one problem, that like one problem is resolved. Here the problem was regarding the size of the data and same view of the data. So these two problems are resolved because now the data is centrally located. So anyone who wanted to analyze this data can connect. It is very simple, right? Anyone. So let's say there is one more person. So this person can also log in using his or her client and can perform the connection with the server. So same view of the data is resolved. Also here, since the data storage is huge, there will be not a problem regarding data limitation or maybe the size of the data. But the second problem, which was over here, which is logical collection and arrangement of the data, how this is resolved. Now let's understand this problem. When we talk about server, the data in server is preserved as folder file format. Now what is folder file format? Let's take one example. Let's say this is my laptop and this is the C drive or D drive of my laptop, and I'm having some photographs with me. I'm having photographs of my parents, of my friend, of my brother, and of myself. Now if I want to preserve these photographs in a logical way in my laptop, how we are going to do this? The best possible way to do this is create folders. So I'll create a folder, let's say A, folder B, folder C, folder D, and I'll preserve all these files in each of the folders. So let's say for parents, I'll preserve everything in folder A. For friend, I'll preserve everything in B. Then for brother, I'll use C, and for myself, I'll use D. So this is known as the folder file format in which we can preserve the data. The same kind of format is used by server. So for each of the business that Amazon is running right now, it will create a folder. So here we have Amazon Entertainment. Then let's say Amazon AWS. Then let's say Amazon e-commerce. Then let's say Amazon Pay. So these are my folders. Within each folder, I will have multiple files. Let's say order file, customers file, then vendor file, then product file, then delivery partner file. So these are my files and these are my folders. So in a particular server, your data is getting preserved in a folder file format. Now please remember, these folders we call as database, and these files are known as the tables. So in a server, you will have, in a particular server, you will have multiple database, and each database will have multiple tables which are connected with each other. But how tables are connected with each other, how this kind of network can be formed, let's try to understand that thing also. So now let's understand how the various tables are managed within each database. So let's create one database, and I'll create a database known as company. So it is the company database, and remember, this is a folder. Now this particular database or a folder is having two files or two tables. One is the employee file, which is having details like employee ID, name, joining date, salary, and department ID. Now it is having some rows. So in SQL or in database, each of these rows are known as records. So they are not known as rows, they are known as records. While each of these columns are known as fields. So the data in a table, this is a table, which is basically the employee table. So this table is having various records and various fields. Now we have one more table, another table, which is the department table. This is having department ID, department name, and let's say number of employees. Again, it is having some records. So this table, let's say this table is named as department table. So I'll write down the name over here, department. This is my table number 2 in the same company database. So in the company database, I'm having these two tables. Now, can you guys figure out what is common between these two tables? The common attribute or the common field that you can find out between these two tables is the department ID. And this is what the relationship is. This is what the relationship is. So in RDBMS, relational, the term relational basically means this. In a database, you will have multiple tables, and all these tables will have their some kind of relationship. Here the relationship is defined using department ID as a common key or common column or common field. Now this particular department ID has a special name. In department table, in this particular table, this field department ID is known as the primary field. Why it is known as a primary field? Because if I have to input any record in this table, I cannot do that without having department ID. So it's impossible to insert any record into a table without declaring a primary field. So a primary field comes with two conditions. Number one is not null. You cannot keep this field as null. You have to declare it. So if I have to enter a record in this particular table, I have to declare department ID. It cannot be missing, and it is unique. It is unique value. So a particular department ID cannot replicate. So I cannot say 12 and 12. This is not possible. This is not possible. So that's the definition of primary field. In the table employees, my primary field is employee ID, but department ID in the employee table becomes foreign field. So what is the definition of foreign field? A particular primary field of a table becomes foreign to another table. So a primary field to one table becomes foreign to another table. So that's what a primary field and the foreign field is. The combination of these two fields create the relationship. Now here you can see one of a schema diagram. Here this customer ID is a primary key, PK, primary key, and this table order ID is the primary key, while these three are foreign key: customer ID foreign key 1, employee ID foreign key 2, shipping method ID foreign key 3. And you can see that all the tables are connected to one another to create a network, and this is one particular database which is having multiple tables. So like any other language, English, Hindi, or any other language, each language comes with components. SQL as a language comes with three components: DDL, DML, and DCL. Now, before we understand what is DDL, what is DML, what is DCL, let's understand two roles: who is a data engineer and who is a data analyst. Now, a data engineer, a data engineer is a person who is the caretaker of the data center or maybe the server. So the person is responsible. So the data engineer will be over here, and this person will be responsible to take care of this particular server. So he or she is the caretaker of the server. Now their task is not to perform analysis. Their task is to make sure that your server is up and running 24/7. So taking care of server. Second thing is their task is to make sure that only authorized users are able to connect to the server, security, and their task is to management. So these are the tasks that data engineers do in their day-to-day life. While on the other hand, a data analyst or a data scientist or maybe a data business analyst, this person is responsible for analyzing the data. So now this person will not be responsible for basically making sure that the data preserved over here is secured enough or not, or maybe they are not responsible. So these data analyst people are not responsible for the server side. They are only responsible to make sure that they are able to answer the business questions. So answering business queries. And for that, they will perform analysis. And for that, they will be using the data which is preserved in the server. So these are the two profiles or the data profiles which you will find out in the RDBMS infrastructure. One is the data engineers, the other one is the data analyst. Now, accordingly, these segments are divided. When we talk about data definition language, which is DDL, now this is basically the set of commands and the set of queries which is used by the data engineering team. So these are those set of commands that are used by data engineering team to create new table, to create new database, to delete a table, to delete a table or a database. Now, please remember one thing, that this is not just limited to data engineering team. A data analyst can also do this, but a data analyst is not responsible to do this. So commands like create, drop, alter, truncate, these are the commands that comes under DDL, data definition language. The second one is data control language, which is DCL. So this was DDL, this is DCL. Now these are also the set of commands and query that is used by, again, the data engineering team. Set of commands that are used by data engineering team to provide. So control means who is going to access the data. So to provide access or to revoke access of a user to the server. So who can access the server? Data engineering team will provide the access or revoke the access for the particular user. So for a particular user to the server. So let's say if Sumit wants to access the server, he will be required to go to the data engineering team to get his credentials. Similarly, if a new person is joining, he will be required to go to the data engineering team to get his credentials. That is what this set of command will do. So here we have commands like grant and revoke. Then we have data manipulation language, which is known as DML. Now this is something which is used by data analyst. And these are those set of commands which are used to analyze the data, manipulate the data. For example, insert update, delete, call, and so on. So these are the three segments of a SQL language with the specific kind of team who use it. We are going to basically focus on DML set of commands so that we can understand how we can use SQL for data manipulation or maybe for data analysis. Let's understand the history of SQL. So let's understand the concept of vendors. Let's say if you have to consume coffee, you can consume coffee from the brand Nescafe. You can consume coffee from the brand Tata. You can consume coffee from the brand Brew. And there are multiple brands that you can find out in market, right? But all of them are selling out the core product, which is coffee. This is the core product, which is coffee, right? Similarly, in the market, RDBMS as a technology or a solution is provided by multiple vendors. So there is a vendor known as Oracle, we have IBM, we have MS SQL, we have MySQL, we have PostgreSQL. These are the various vendors who are available in the market which are providing RDBMS as a technology. Now all these vendors will have their own server and client infrastructure. So what difference you will find out? So if I talk about this example, here all of them are selling the same product, which is coffee. But the difference that you will find out is with the flavor. Nescafe flavor will be different, Tata flavor will be different, Brew flavor will be different. So the difference is in the flavor. Similarly, in all these vendors who are providing RDBMS as a technology, you will find out difference in their user interface, which is the client. So this Oracle will have a different client, IBM will have a different client, MySQL will have a different client. Sorry, MS SQL. For MS SQL, it is known as the management studio. Management studio. For MySQL, it is known as the workbench. MySQL workbench. Then for Postgre, it is a different client. So you will find out difference in client. But what is common is SQL. So no matter on which particular platform you are going to work on, you will find out SQL to be 99% similar across all the vendors. Now, why I am not saying 100%? Because you will find out that some of the functions are differently used in different platforms. So in MySQL, you will find out some of the functions are differently used. In MS SQL, you might find out more additional functionalities. In PostgreSQL, you might find out more additional functionalities. But the core SQL, the base SQL is similar across all the platforms. Now, before we proceed forward, let me just give you a quick history of how and who invented RDBMS. So in 1970, there was a person who was working in IBM named E.F. Codd. So this person introduced and released a paper in the market regarding relational databases, relational tables. Now, when this person E.F. Codd in 1970, at that time he was working with IBM, released his paper relational database or relational tables, he asked the IBM management to work on his idea. He asked IBM that this is something which can help the IBM team to efficiently manage the data. But IBM team was not so much interested in putting additional cost. So what E.F. Codd did, he started reaching out to the clients of IBM. So when there was a pressure from the client, because clients want everything to be quick and fast. So E.F. Codd explained how relational table, his idea, can be beneficial for the clients. So clients started pressurizing the IBM team. And that is how in 1974, IBM team started working on the idea of E.F. Codd without having E.F. Codd in the initial team. So the team that started working on the idea of E.F. Codd was not having E.F. Codd in the team because IBM was not happy with the step that E.F. Codd took. So in 1974, they started working, that IBM team started working on the idea of E.F. Codd. But meanwhile, since E.F. Codd already released the paper, the Oracle team were already working on his idea. So in 1978, Oracle launched the very first commercial RDBMS system. And that's how Oracle became the first company in the world to introduce the first commercially available RDBMS system. Whereas IBM became the second company. Now, SQL, the term SQL, was something which was introduced by the IBM team. So when IBM team was working on the relational database management system, they found out that in order to communicate between the server and the client, uh, the particular person has to write a very sophisticated code, a very sophisticated query, which was difficult for any general person, a non-technical person. So IBM team drafted and they created a language altogether, which they call as SEQL, SQL, and this language was further known as SQL, which is structured query language. So in nutshell, just to give you a summary, the person EF Cord is basically the father of this idea, a relational database management system in 1970. Oracle became the first company to get it commercially implemented, while SQL was developed by the IBM team, and they introduced what SQL we know today. So this is the platform which we are going to use. Now this is basically client, and here if you carefully read, it says MySQL Workbench is a official graphical user interface, which is GUI tool for MySQL. I hope you guys remember that we are having MySQL as a vendor. So this vendor comes with two components, the server and the client. The server is something which right now is locally installed in my system. So I do not have a server or maybe a data center. I'm running a local server which is running in my laptop infrastructure itself. And this interface which you can see right now is basically the client. Now if I want to connect to a server, I can simply click on this plus sign, and there are basically various details that you have to input: the connection name, host name, port, username, password. These are the 4 details that you need. What is the host name, port, username, and password? And when you will be joining any company, they will be providing you with these 4 details: the host name, port, username, and your password. And you have to put all these details over here, text the connection, click OK, and you are done. Now let's launch the SQL Workbench. So here we are connecting with the server, which is my local server. And now we are going to launch a new space. Now this is basically on the left. What you see right now is basically the various databases that are available to us, and these is basically the place where we can write a query. Now before we can write a simple SQL query, we have to understand one thing. As we already know that in a database we have multiple tables: table 1, table 2, table 3. But there is one thing that you guys need to understand, that in a data center or a server, you will have multiple databases, right? So this is my server. In this server I'm having, this is my DB1, this is my DB2, and so on. So this particular server is also known as a data warehouse, which is having multiple database, and database is having multiple tables. Now which particular database I wanted to query? So first of all, I have to select a particular database, and then on that database I can select a table. So how we can do that? I'll first of all write, so let me just zoom it a little bit. I'll write use HR. I'm basically asking my SQL server to utilize or to use or to query on the HR database. So use HR semicolon. I'll select it and press on this run button, and you can see that it is activated. So now we have updated, or maybe we have selected the particular database with which we wanted to work. Now we wanted to query a table. I wanted to look into the details of a table. So the way we write a simple query to look into a table is select, then which particular table. So I want to look at all the rows and columns from the table, let's say employee. So a particular SQL query will look something like this, which is having the component select. So I'm asking my SQL server to select star means all rows and columns, all records and field from the following table, and this semicolon is end of query. So this is a general schema of how you write a SQL query. Select star from particular table. Let's see. If I say select star, then from employees, semicolon, and I can use a shortcut key also, which is Control Enter, but let's select it and run it. And here you can see we have the result. Let's say I'm only interested in getting few columns or few fields, not all the fields. So instead of star, we can mention the name of the columns. So select, let's say I need first name followed by last name from the table employees. So here we have defined the column names, columns we want to extract. So that is how we can select specific columns. Let's see. Select, I want first underscore name, last underscore name, and please remember, since SQL is case insensitive, I do not have to worry about the case. Here the case is all capital, but still I'm using small cases. Not a problem because SQL is case insensitive. Then I need, let's say, employee ID from the table employees, and let's execute this, and you are done. Now let's understand how we can filter the data. So let's say I want, so let me execute this one. Let's say I want all the employees working in department 90. Now again, this is very straightforward and simple. The way we write or the way we talk is the way we are going to write. I want my SQL server to select all the rows and columns from the table employees where, now where, then we have to write the condition where department ID is equal to 90. So this is again very simple. I'm saying select all the rows and columns from the following table where, this is basically the clause that we use to declare the condition, and this is my condition. Now this condition can have, so for is equal to, I'm using equality sign. For greater than, for less than, for not equal to, you can use this, or you can use exclamatory mark equal to. So this is equal, greater, less, and these two are not equal. So let's see one example. I can say select all the rows and columns from the table employees where department ID is equal to 90, semicolon, and run. So here I'm having 3 rows. If let's say I want to select all the rows and columns from the table employees where the salary is greater than, let's say, 5,000, then this is how we can do it. Now please remember one thing, I can write this query in 1 line also. There is no requirement to write it in 3 lines. But since I want my query to look structured, I follow this kind of mechanism. So it is always a good practice to write your query in various lines so that it is readable and very clean. Okay, now how we count? Let's say I'm having a table, and this is my table, which is having employee ID, name, and department ID, and salary. Let's say this is my table. I'm having few records. Let's say I'm having 4 records. Employee ID is 01, 02, 03, 04. Name is A, B, C, D. Department ID is, let's say, 5, 7, 5, and this is missing. Salary is 10, 11, 12. Now in this particular case, if I ask you to find out the number of records, how we can do this? I'll simply say select count of, so count is a function. I want to count employee ID from the table employees. Select count of employee ID from the table employees. Now this will return you the result as 4 because count of employee ID is 4. If I say select count of, instead of count of employee ID, I'll get the same result 4. if I say select, or let's change something. Okay. If I say select count of department ID, DID, from the table employees, in this case, I will get the result as 3. I'll not get 2, I'll get 3 because it is just counting. It is not counting distinct, it is just counting. But instead of providing a specific column name, I can also use select count star. Now, when you say count star, you are basically counting a row, a record. So I'm saying count star means count or consider all the columns. So this is one record. This is second record. This is third record. This is fourth record. So count star will give you the answer as 4 because it looks at record. And if you justify or specify the name of the column, it will look at the values in that column. So star is a better option if you wanted to count all the rows. But if you are looking at the specific columns, then please make sure that the column should not have missing. If it is having missing, you will get the count of all the available values. It will not be counting the nulls. Is that clear, everyone? Yeah. Okay. So let's see example. Select count star from the table employees where department ID is equal to 90 semicolon and run. And if we have the answer as 3 because this particular department is having 3 employees. Similarly, if I have to find out, let's say, sum, minimum, maximum, all the parameters or maybe all the functions are available. So let's say I wanted to find the sum of salary from the table employees where department ID is equal to 90. So this will give you the total salary. Similarly, I'm having maximum. If I need the maximum salary, I'm having minimum if I need minimum salary. Then we have average if I need the average salary. So these are the various aggregation functions which you can use with the select clause to get various summary metric.
So I hope you guys would have enjoyed listening to me and have understood how to start with SQL, what is RDBMS, and how to write a simple SQL query. Now that was all about this particular video. I'll be looking to you in the next video. But before we end this video, don't forget to subscribe to our channel Session with Sumit. Give this video a big thumbs up and share this video with every friend, every co-learning friend who is looking to learn SQL. So see you in the next video. Till then, keep learning.